ladies and gentlemen. Welcome to Denimalo Tutorials. Today we are looking at Rankine cycle, but mainly focusing on how to interpolate these given values. So here we are given our question, which is saying a simple Rankine cycle works between pressures 28 bar and 0.06 bar. The initial condition of system being dry saturated. Calculate the cycle efficiency, work ratio, and the specific steam consumption. So here we are going to first draw our TS diagram. Here T for temperature, then S for enthalpy. Since on our given values, we are seeing that we are not having the superheated steam, so there's no need for drawing that sharp curve going upwards here. So I just write 1, 2, 3, 4, 5 here, and this line is representing for the saturated vapor. This line is for the saturated liquid. Then this one is for the saturated vapor. And then here we know that here on top, this is where we are having the pressure 1, and then here where we are having the condenser here. This side we are having the condenser below here. So this is where we are having what? The pressure 2 and temperature 2. So this is the TS diagram. Then we are going to jump on steam pressure. So our steam pressure given here, which is the pressure 1, our steam pressure, which is pressure 1, is 28 bar. As we know that on our steam table, our units for pressure given in kilopascals, so we have to change the given bars to kilopascals. So it means we have to change this 28 bar to kilopascals. So when we are changing the bars to kilopascals, we just multiply by 10 to the power 5, and then we split this 10 to the power 5 to be 10 to the power 2 times 10 to the power 3, where we are going to just multiply by 10 to the power 2, and then this 10 to the power 3 is going to represent for the kilopascals. So we are going to left with the 2,800 kilopascals here on pressure 1. After having this pressure 1, as we know that when on the pressure 1, we have to just write the H1 and S1. So we have to find the H1 from our steam table. So you have to look for 2,800, so that we'll be able to find for H1. As we know that our H1 is equivalent to Hg, so you have to search for 2,800. So here we are going to see that we are not having this 2,800 here. We are just having this 2,750 and 3,000. We are not having the exact value of 2,800. So we are going to take these numbers. These are bounded our 2,800 here. So here we are going to just write 2,750 as our pressure here, and then 3,000. These are the numbers. This is the range where we find the 2,800 here. So you are going to write 2,750 and 3,000 here, and then after writing this, we have to take the H1s for 2,750 and the H1 for 3,000. So this is how we are interpolating. So this is where we are introducing interpolation. So interpolation is when you did not find the exact value of the pressure you are required here. So here we have to find the H1 of 2,800 pressure, but we are not having this 2,800 pressure. So you have to take the range of numbers that is between the what that number. So we are saying that this 2,750 and 3,000, in between these numbers, this is where we can find 2,800. So here we are going to take the Hg for 2,750. So 2,750, we are going to take the Hg. So the Hg for 2,750 is 2801.67, and then the Hg for 3,000 is 2802 0.18. So after having these values now, you don't have to forget that we need the HG for 2800. So after obtaining these values, we have to subtract these two numbers here. So we have to subtract these two numbers here we are given here. So we have to say this number, we have to subtract this number from this one. So we are going to say 2802.18 subtract by 2801.62, and then we are going to get 0.5. Then after getting the difference we are having here, we are also going to find the difference here. So we are going to say 2700 from 3000, then the difference we are going to get 250. Then after getting this 250, we have to divide here. So if we divide, we are going to see that our answer is going to be 0.00204. Then now we have find out that each gradual here from here was from here to from 2750 to 3000. We are having 250 graduals. Then each gradual is represented by 0.0024. So now we know that from 2750 to 2800 we are just having 50 graduals. So it means if we need the 50 gradual here, we have the value of the 50 gradual, we have to just multiply this number which is representing each gradual by 50. So we are going to say 0.00204 multiply by 50, and then we are going to get 0.102. Then after getting this number, now this is the 50 this is the value of the 50 gradual here, which is 2800. So we have to add the 50 gradual here to the number we are already having here. So we are going to say 2801.67 plus 0.102. So we are going to say 2801.67 plus 0.102. So our answer is going to be 772 kilojoules per kg. This is our H1. Then after finding this H, now we're having our H1. So we have to also find the S1. So on S1, we are also going to interpolate, because we need the S1 of this 2800. So now we are knowing that we're just on our pressure, we are just having this 2750 and 3000 here, and then we are going to check the corresponding value of SG of this 2750. So we are going to see that our corresponding value here, 2750 of SG, it's 6.2170, and then of 3000 here SG, this one is going to be 6.1832. Then after having this, we are going to repeat the process as we're doing there, but there's a thing we have to know. We have to check if our values is increasing, because our values are supposed here, the numbers we are having here. You have to check our numbers increasing or decreasing. If our numbers are decreasing, it means at the end we don't have to add here, we subtract. So here we are going to see that we are going to see that the pattern we are having here is decreasing, because if we are going to check this, the number we are having here is 6.2107, and then the value we are having here is 6.132. So it means the answer we are going to get here for the 50 gradual, we are going to subtract it from this number. So what I'm saying here is we are going to say the given number, you are going to say this 6.2170 subtracted by 6.132. So now we have to subtract here. So if we subtract this 6.2 by this, we are going to get 0.0338. Then we are going to do the same. We are going to subtract this 2,700 from 3,000. Then we are going to get 250. Then if we divide there, we are going to get 0.0001352. This one is the value of each gradual here. Then we know that from this 2,750 to 2,800, we are having 50 graduals. So you have to multiply this by 50. So if we multiply this number by 50, we are going to get 0.00676. Then after getting this value, what I was saying is after getting this value of the 50 gradual, now we are not going to add here, we are going to subtract. Why? Because we are saying that the pattern we are having is decreasing, but we are going to see that this number is bigger than this, so it means the pattern we are seeing here is decreasing, it's not increasing. So it means the value we are going to get here for the 50 gradual, we are going to subtract it now. We are not going to add because our pattern is decreasing. So here we are going to say 6.2170 subtract by 0.00676. So we are going, our answer is going to be 6.21024 kilo joules. This is the value for our S1 now. So now we are done with the interpolating. We have got the value for we get the value for our H1 and our S1. It means we are done with the pressure with pressure 1. So now we are going to jump on pressure 2, which is the condenser pressure. So on the condenser pressure, we are given 0.06 bar. So we have to change this to kilopascals. So it's going to be 6 kilopascals. Then we are going to check if we are having this 6 kilopascals. So we are going to see that we are having our 6 kilopascal here. So there's no need for interpolating. So here we are just need the value of HF there. So you have to find HF of 6 kilopascals. So the HF of 6 kilopascals the HF, our HF is here. It's 1 4 6. Then we are going to HFG, and then on HFG of 6 kilopascals, HFG, which is here, we are going to see that it's 2416.40. Then we are going to take SF of 6 kilopascals. So our SF is here, so 0.5208. Then our SFG, we are going to take 7.8106. Then after having these values, now we have to find our H2, where the formula of our H2 is saying HF2 plus X of HFG2. So here we have to firstly find the value of X for us to be able to find this H2. So for the value of X, you have to write the formula S1 of SF2 plus X of SFG2. So here we are going to write our S1. Our S1, we are having it here. This is 6.21024, which is equals to our SF2, this one 0.5208 plus X, we are in need here. Then actually here we are not having enough space, so let me write it here, plus x, then SFG 7.8106. So our x is going to be, if you punch on the calculator, you're going to see 6.210.4 subtracted by 0.5208, then divide the answer by 7.8106. Then we are going to see that our x2 is going to be 0.7284. So after having this x, we don't have to forget that we're searching this x, so that we'll be able to substitute it here, so that we'll be able to find our h2. Then our hf2 we are already having it here, 0.46 plus our x here, 0.7284. Then our hfg here, is 2416.40. Then our h2 is going to, if we punch this on the calculator, we are going to see that our h2 is going to be 1911.57 kilojoules per kg. So after having this information, now we have to go, now we are able to go to the question. And our first question is saying calculate the cycle efficiency. Now, so you have to calculate our cycle efficiency using the information we have obtained. So now, for cycle efficiency, we have to know the formula for cycle efficiency. And then our formula for cycle efficiency is our cycle efficiency is equals to work net over Q1, whereby our work net is equals to work turbine subtract by pump work. Then the work turbine we are going to get it by saying H1 subtract by H2, and then we are going to see that our H1 here are already have it here. So our H1 we are going to take it here, which is 2801.772 subtracted by our H2. Then our H2 we are having it here, which is 1911.57, and then our work turbine is going to be 890.202 kilojoules per kg. Then now, after getting this work turbine, you have to find work pump, where our work pump formula is VF2 multiplied by change in pressure, whereby this VF2 we are going to just take our steam table and go on 6. On 6 here, we are going to see that our VF2 is just here, which is 0.001 here 006. Then we have to multiply it by the change in pressure. Our change in pressure is pressure 1, which is 28, subtracted by pressure 2, which is 0.06. Then the answer we are going to get here, we have to multiply it by 100. It's like that our unit is going to be in kilojoules per kg. So it means here, if we multiply it correctly, we are going to get 2.81 kilojoules per kg. So after now we are having our work turbine and then our work pump. So meaning to say we are done with this thing of working it. So now we have to go to Q1. How are we going to get Q1? The formula for getting Q1 is H1 subtracted by HF4. So our H1 we are already having it, but HF4 we are not having it. So you have to write the formula for getting HF4. HF4 is equals to work pump plus HF2, and then our work pump is here, 2.81 plus, then our HF2, we're going to take our paper here, we have our jot down, so we're going to see that our H2 is 151.46, so we're going to write 151.46, and then our HF4 is going to be 154.27. Then after that, now we are able to find this H1. So what we're going to do now, we are just going to write our cycle efficiency equals to a work net, which is work turbine. Our work turbine is 8.202, then subtract by work pump, then our work pump is 2.81 here, subtract by, then Q1 is H1. So our H1 is what? We're having our H1 here, 2801.772, subtract it by HF4. HF4 having it here, 0.27. So we have to know, if we are in the process of finding efficiency, you have to multiply the answer by 100%. So if we let us punch our calculator here, we are going to see that our answer is going to be 33.5% here. So we are done with efficiency. Then after that, we are having work ratio. So on work ratio, then how to find the work ratio? You have to know the formula for work ratio. So our formula for work ratio is equals to work net over work turbine, where our work net here, we are already having it here. This one is our work net. So we're going to just say 0.2002 separated by 2.81 all over our work turbine. This is the work turbine, because the work net is saying work turbine separated by work pump. So we are just going to take this work turbine here, 0.2002 here, and then you have to punch this on the calculator and then check the what, our answer we are having there. So we are going to see that if we punch correctly, we are going to get 0.997 here on the work ratio. Then I'm done with the work ratio. Then we are going to also check the specific steam consumption. So the formula for specific steam consumption is equals to, you have to just write 3600 over work net. So I'm going to say 3600 over our work net is, you're already knowing it now, 2 minus 2.81. So what are we going to do now? We have to just punch, then our answer, let's punch it. So our answer is going to be 4.06 kg per kilowatt hour. So thank you guys for watching. Don't forget to subscribe, like and share